Thank you so much for joining this lesson. We're going to discuss mathematics paper 2. This is a joint examination which has been done by more than 63 schools. So you're supposed to know that it's a well thought out paper, and I hope you people shall benefit during this presentation. Remember to subscribe, remember to share so that you may invite a friend. Our consultation line remains 07 04 15 33 66. So you can reach out to us for more programs. We're going to discuss the section 1 of this paper and later the section 2 of the same. Number 1, solve for x in the log of x plus 4 to base 5 minus 2 equals to the log of x minus 4 to base 5. So we're going to apply a few laws here that govern logarithms. I'll be stating the laws, then I apply them. We know very well that in logarithms, there is a law that says in case we have the logarithm of a certain number to the same base, this one is equivalent to 1. Now, looking at this question, there is a constant 2 which has been applied. Therefore, at that point, I shall introduce the logarithm of 5 to base 5 because the value is 1. I will not have affected the value of 2. So I rewrite now my equation as the log to base 5 x plus 4 minus 2. And now I write log of 5 to base 5 equals to log to base 5 of x minus 4. Now, at this point, I can apply a law that will govern my left-hand side because I can see subtraction somewhere. The second law of logarithm says that in case we have the log of a certain number, say b, to base a, then minus the log of a different number c to the same base a. This one will be solved by taking the logarithm to base a, then b and c shall be divided that way. So using this law, we apply it on the left-hand side such that we have the log to base 5 x plus 4 divided by all right, allow me at that point talk about the third law, which says n, the log of a is the same as log of a power n. Therefore, instead of 2 log 5 to base 5, now I can have log of 5 power 2. Log of 5 power 2. And remember, 5 power 2 is equivalent to 25. Yeah, 5 power 2 equals to 25. This is equal to the log to base 5 x minus 4. Therefore, we had to apply a law at this point such that this changes to log to base 5 of 5 squared. So we bring the power 2 there. In other words, 2 becomes a power according to this law. Then 5 power 2 is 25. Then now we go to the second law. At this point now, we cannot apply any further laws of logarithms. So we can directly equate the left-hand side and the right-hand side after dropping the logarithms. X plus 4 over 25 equals to x minus 4. After cross multiplication, I'll be having x plus 4 equals to 25x. Yeah, when I multiply by 25, to be 25x minus 4 by 25, 100. If we group terms now, this will be This is going to be 24x. Yeah, 25 minus x. 25x minus x becomes 24x. Then we will have 104 on this side. So that when 104 is divided by 24, we get 4 and a third. So the value of x equals to 4 and a third. That is the final answer in the question number 1. Now let's look at number 2, which is a question from a binomial expansions and expressions. For us to expand and simplify, and remember we've been told up to the term with x power 3. So we must be very careful with instructions. We are not giving the full expansion. We are just expanding up to the term that will contain x power 3. So we first list the binomial coefficients of power 5. And they are usually 1, 5, 10, 10. Actually, we are expanding up to the fourth term, because when we start with the x at power 0 in the first term, x will assume power 3 at the fourth term. So we are just expanding up to the fourth term, not the full expansion. So in the first term here, we expect 2 to be raised to power 5, but negative a fifth x to be raised to power 0. So that in the next term, we have 2 taking power 4, but negative a fifth x taking power 1. Then in the next, we'll have 2 going down to power 3 and negative a fifth x ascending to power 2. And finally, as 2 gets to squared, negative a fifth x will ascend to power 3 that way. So the powers of 2 start from 5, then they start decreasing. The powers of negative a fifth x begin from 0, but they start ascending as they alternate. So that is what happens. Now we can expand and write our expansion. 1 multiplied by 2 power 5 is 32. Then anything power 0 is just 1. So 2 times 32 times 1, we get 32 as the first term. The next term shall be 5 multiplied by, 2 power 4 is usually 16. So 16 times 5, and anything power 1 remains the way it is. So we multiply by negative a fifth. When we multiply by negative a fifth, we shall get negative 16. X is now introduced. In the next term, which is starting with 10, then 2 power 3 is 8. So we are having 10 times 8 multiplied by negative a fifth x is now squared. So it will be 1 out of 25 x squared. So we are having 10 times 8, then multiplied by 1 out of 25. This is going to give us 3 and a fifth, but it's now positive. 3 and a fifth x is now squared. Then in the last term, it will be having a minus 10 multiplied by 2 power 2, which is a 4, that is 40. Then negative 1 over 5 x power 3. It shall remain with a negative because the power here is odd. When the power is odd, then we get the negative retained. When the powers are even, we usually have a negative to simplify another negative. But here, one negative shall remain without being simplified. So 5 power 3 is a 125. So we'll be having 1 out of 125, but negative. 10 times 4 times 1 out of 125. So negative 8 out of 25. And x is raised to power 3. So now we are having the expansion up to the term that contains x power 3. Look at number part B of the same. use the expansion in A above to estimate the value of 1.96 raised to power 5. So this is how we apply it. First, we equate the expansion to minus 1 over 5 x power 5. We equate it with 1, 9 power 6, 1.96 power 5. And we say because the bases are the same, because the powers are the same, then it means we are having equal bases. So 2 minus the fifth x equals to 1.96. We group terms here, and we can have 1 over 5 becoming positive on the right hand side. Then 2, we minus 1.96. That will be 0.04. 0.04. So how do we remain with x? By multiplying by 5 through. This gives us exactly 0.2. So the value of x is 0.2. In the previous expansion now, we shall substitute the value of x as 0.2. Remember, we are just estimating because we are not using full expansion. In case we had done the full expansion, we would get the exact value, but now we shall just get an estimate. So 32 minus 16, 0.2 plus this one, I'm going to have it as a 16 over 5. Yeah, 16 over 5. For efficiency in my calculation, let me have it that way. This now becomes squared. Minus 8 out of 25. Then 0.2 shall be cubed. Then in my calculator, I'll just write this one as it is. I start by 32, then minus 16. I open brackets 0.2, I close the brackets, plus 16 over 5. I open brackets 0.2, I close brackets and square. Then I minus 8 out of 25. I open brackets 0.2, I close brackets and cube. That way. So I'm getting 28.92544. That is the exact answer that I'm getting after the expansion. So that is it. That is how you apply such things. Look at number 3. A coffee blender mixes 2 types of coffee, X, which costs 125, and Y, which costs 160. She sells the mixture at 182.5 Kenya shillings, thereby making a profit of 25%. Find the ratio XY at which she mixed the 2 types of coffee. In this question of mixtures, what we're supposed to know is that this business lady is making some profit of 25% after selling the mixture at 182.5. This is to mean that there is the cost price of this mixture that was arrived at after mixing. So what is the cost of a kilogram of this mixture? Yeah, what is the cost of a kilogram of the mixture? So we're going to tell ourselves that 125% is equal to 182.50. What about 100%, which will be now the cost price, because 182.5 is the price including the profit. So this shall be 182.50 multiplied by 100 out of 125. This is going to give us 146. Yeah, 146 that way. So we are having X and Y. X costing 125, Y costing 160, but mixed to give us a mixture worth 146. So we're supposed to subtract across such that we take 160 minus 146, we get 14. Then we also get 125 and 146 subtracted, we get 21. So the ratio into which X and Y have been mixed is 14:21, which can be simplified by 7:2 and by 7:3. So a ratio is supposed to be left in its simplest form. You are not supposed to leave unsimplified ratio. It will not earn you the final mark. That's one method that you can use by just subtracting. But now we can also do it in a different way. We say that we are mixing X kilograms, each costing 125. So 125 multiplied by X kilograms plus 160 multiplied by Y kilograms. So that will be the total cost of the mixture. But when we divide by the number of kilograms making that mixture, X kilograms of the first brand plus Y kilograms of the other brand, you divide by the total number of kilograms. You discover that the price per kg is going to be 146. So this is an alternative working. A student can use this method where you say the total cost of this mixture divided by the total number of kilograms. They should give us price per kilogram, which is 146. That means we now be having 125 X plus 160 Y equals to 146 X plus 146 Y. That way. Then now we can group terms whereby I can even begin by X together. 146 minus 125, that will give us a 21X. Then when I take 160 and I subtract 146, I'm supposed to get 14Y. At this point now, to remain with X alone, I'm going to divide through by 21. So I'll be having 14Y out of 21. For me to remain with the constants on one side, that is 14 over 21, I'm supposed to divide it through by Y. So X over Y. At this point, if X over Y equals to 14 over 21, which can simplify to 2 over 3, then it means the ratio of X is to Y equals to 2:3. This is a recommended approach also. You can follow it. Let's get to number 4. Madam Lydia owns a second-hand saloon car, whose current value is 350,000 Kenya shillings. The value of this car has been depreciating at 6% for every 6 months. 6% for every 6 months. Find the value 3 years ago. Find the value of the car 3 years ago. This is commercial arithmetic, and we are talking about depreciation. Now, in depreciation, we're supposed to know that a value, new value, is given by principal, and principal is original value into 1 minus the rate of depreciation, which is a percentage, so of 100 raised to n, the number of periods of depreciation. So when we substitute into this formula, we'll be able to get what we are not having. Find the value 3 years ago. So the value we are having now is 35,000. So that means there is an original value that was there. 1 minus a rate of 6 over 100 raised to the number of depreciation seasons here. The rate of 6% is for every 6 months. So how many 6 months are in 3 years? How many periods of 6 months are in 3 years? Every month, every year is having 2 seasons of 6 months. The first 6 and the last 6. Again, another 6, the last 6. And finally, another 6 and the last 6 months. Therefore, 3 years can be divided into 6 seasons. So the language here at the rates, 6% for every 6 months is the one that will guide us. So n will not be used as 3. It will be that way. So we don't know the value it was 3 years ago, but with this kind of depreciation, it has come to 350. So we can get that value it was. So we will talk about now 350,000 being equal to. Now here you make good use of your calculator. You take 1 minus 6 over 100. Then this answer you raise it to power 6, sorry. Just raise it to power 6. Then after that, now you know I'm getting 0.6899. This is an estimation multiplied by P. Then to remain with P, I have to divide now. So 350,000, I divide by the answer here, which is 0.699, and I'm getting 507. 507,342.124 Kenya shillings. So that is the value of this car 3 years ago, because it has been depreciating. That is why currently it is at 350. So that's how you work it out. You just read the formula and you substitute until you know what has not been provided. So we are not finding value. We are finding the principle. It is the principle which is not known. So that is it. Thank you for following. Thank you for being around. I recognize you people. You can comment. Please check on us. Let us know whether you're getting us clearly. Let us know the school you come from. Let us know where you're watching us from. Let's know whether you are getting something from Shifting Grades. Have you invited a friend to Shifting Grades Online School? Please do so. Invite schoolmates, invite friends, even from different schools. This is a joint examination done by a group of schools. More than 60 schools sat for this paper. And I've told you, indeed, it's a good examination. Number 5, a quantity A is partly constant and partly varies inversely as a quantity B. Given that A equals to -10 when B equals to 2.5 and A equals to 10 when B equals to 1.25, find the value of A when B equals to 1.5. This is a partial variations. When you see the word partly, just know that we're dealing with partial variations and not joint variations. So we're going to interpret the first statement from English into mathematics. So let's make it a mathematical statement now by saying that quantity A is varying partly as a constant. Then the other part, it's varying inversely as quantity B. So when you hear inversely now, the reciprocal of B. At that point now, we can say that quantity A, we do away with the symbol of proportionality. This one is called the symbol of proportionality. So we do away with it and we introduce an equal sign, then 2 constants. So partly constant and partly as the inverse of B. So we introduce another constant multiplied by the reciprocal of B, which becomes, if the constant is C over B. In this case, K and C are constants. K and C are constants. If that is so, then we can now interpret the next information, given that the value of A equals to -10 when B is 2.5. So A is -10. So K plus C out of when B is 2.5. That is one equation, but we can simplify it further by doing away with this fraction decimal by multiplying through by 2.5. Every term by 2.5, it becomes 25, but a negative equals to 2.5 K plus C. That is after multiplying C by 2.5. So the 2.5 will cancel at C. Then some more information. A equals to 10. So K plus C. When B equals to 1.25, we do the same here. We multiply by 1.25 through, so that we have 12.5 equals to 1.25K plus C. That way, to do away with fractions which are decimals. So with equation 1 and equation 2, we can solve them simultaneously, whereby I shall apply what we call the elimination method. Looking at the value of C, we discover that the coefficients of C are the same in both equation 1 and equation 2. So I can subtract directly. C minus C, that one cancels to a 0. 2.5 minus 1.25, that gives us 1.25K, equals to -25 minus 12.5. This is -35. -37.5, sorry, that way. So that the value of K will be, when we divide through by 1.25, I'm getting -30. So the value of K is -30. If the value of K is -30, then we can easily get the value of C by going to one of the equations. And let's say in equation 2. In equation 2, we can say this. The value of C, or let me just substitute first. 12.5 equals to 1.25, the value of K, -30, plus unknown C. So we can remain with C here and say that 12.5 we will add 30 times 1.25, and this will give us exactly 50. Yeah, I've added because -30 multiplied by that value, it will become a negative, but now we have to take it to the left-hand side, whereby it shall be added that way. So with the C and K, we can write the general equation, which is supposed to be A equals to the value of K, -30, plus C, which is 50, out of the value of B. With this equation connecting A and B, we can find the value of A when B is 1.5. Find A when B is 1.5. So the value of A shall be -30 plus 50 out of 1.5. This is giving us 3 1/3. 3 1/3. So that is the value of A when the value of B is 1.5. That is it. Let us look at number 6, which is a very good question on vector 2, proportional division of a line. Given that O is the origin and that vector OA equals to 2i plus 2j minus 4k. And again, vector OB equals to 6i plus 10j plus 2k. And that point R divides AB externally in the ratio 3:1. Find the vector OR. Look at the word externally. That's what will guide us in this question. This is a very serious question. And actually, in Shifting Grades Online School, this platform, during your own time, please search external division of a line or external division of a line, vector 2 mathematics. You are going to find more other questions which are like this number 6, and they will guide you to know how to interpret a ratio when it divides a certain line externally. And by that doing, you really benefit. So even if we are not live, there are enough lessons for you in Shifting Grades that you can follow up with. So please be standby, follow with our programs, and you guys shall benefit. Now, I'm supposed to first explain what the external division means. Look at this. We are having a point A from the origin, another point B from the origin. Then now comes point R here. Now, when we are told externally, it means from A to point R, we are having 3 divisions according to the ratio here, 3:1. 3 divisions. So from A to where point R is, there are 3 divisions, a total of 3 divisions. Then from R back to where B is, we have 1 proportion. That is what it means by 3:1 externally. From A to R, 3 points, and from R back to B, 1 proportion. So we are having 1 proportion here, and because from A to R, there were 3 proportions, then it means we have now remains with 2. That is it. Now, another way of stating an external division, you can be told point R divides AB. Assume you are told this. R divides AB in the ratio 3:1. Now, it would mean the same. 3:1. Now, you don't have to be told it is external. By the appearance of the negative, you should understand that we are dealing with an external division. So external division can either be mentioned that it is external, or we have the question without the word external, but we introduce a negative to mean external. That way, to mean external. So this is an external division. And what does it mean? Okay, assume, for you to understand better now, let me give a different value there. Assume we are told that R divides AB in the ratio 5:2. It means this, that from point A, there is a B here, then R, which is dividing externally, divides AB externally. Let's interpret a second ratio here for you to know how I have interpreted the first one. R divides AB externally in the ratio 5:2. It means from A to where point R is, we are having a total of 5 proportions. But from where R is back to B, we are having 2 proportions. So we will have 2 proportions here. But because the total from A to R were 5, now there remains a 3 at this point. So that's how you interpret external division. Instead of being told externally in the ratio 5:2, you can be told simply in the ratio 5:2. It will mean the same. So now back to our specific question now. Now that we have known the ratio into which point A, B, and C are having, we can now apply what we call the ratio theorem. The ratio theorem says this is a general statement now. Let me give the ratio theorem. Assume we have a line here which has been divided We have a line P, Q, and it has been divided by a point X in ratio M is to N. According to the ratio theorem, we say this. In case we get proportion M, divide by the total proportions M plus N. Then because we have picked M, we multiply it by the opposite vector, which is Q. Then we add, we take proportion N out of the total proportions M plus N. And because we have picked N now, we multiply by the opposite vector P, we're supposed to get vector X that way. This is now the general statement of the ratio theorem. Now with the general statement of the ratio theorem, according to the above analysis of A, B, and R, the coordinates of A can be determined. We are going to write vector A as column vector instead of the position vector, whereby now we shall have 2, 2, negative 4. 2, 2, negative 4. Then vector B is going to be 6, 10, 2. 6, 10, 2. That way. And R is unknown, X, Y, Z. Now, according to the ratio theorem, vector B, which is 6, 10, 2, equals to, when we take 2, the ratio 2, out of all the proportions, which are 3, because we picked 2, we multiply by vector R, X, Y, Z. We're supposed to add, we take 1 here, the ratio on this other side over total proportions, and we divide by the opposite vector, which is A, 2, 2, negative 4, that way. So now we can get the values of X, Y, and Z. X, Y, and Z, we need to use the X components. X equals to 2/3 X plus 2/3. Yeah, 2/3, because 1/3 times 2 becomes 2/3. Now at this point, we can say 2/3 X equals to 5 1/3. Because 2/3 must be subtracted from 6. And for us to remain with X, we divide 5 1/3 divided by 2/3. 5 1/3 divided by 2/3, or simply times 3/2. Yeah, times 3/2, we get 8. Times 3/2, so that we do away with the coefficient of X, both sides. So we go to the Y components, whereby we talk about 10 equals to 2/3 Y plus, again, 2/3. So we shall talk about 2/3 Y being equal to 9 1/3. So that the value of Y can be given by 9 1/3. We multiply by 3/2. And that gives us exactly 14. Then for Z, we talk about 2 equals to 2/3 Z plus, here we are having a 1/3 times -4. That becomes -4/3. So we can talk about 2/3, the value of Z, equals to 4/3 should be added. So 2 plus 4/3. This gives us 3 1/3. And then the value of Z can be gotten by multiplying by 3/2, both sides. 3/2, both sides. That gives us exactly 5, and it's still positive. So now the vector, the position vector of R is 8, 14, 5, and it can now be given as a position vector, which is a 8i, 14j, and 5k. So that's how we get, that's how we get the position vector of R. Number 7, a very good question here. The following figure shows a circle center O. So we have a circle here, whereby the center is O. I hope I've brought it well to you. I hope you can see the whole grid showing us the circle. Then after we have seen this circle, what are we told to do? Part A, determine the equation of the circle. Determine the equation of the circle. For us to get the equation of the circle, we need the center and the radius. So the center will have some coordinates, and according to the grid plotted here, this center is having coordinate 1, 2. Coordinate 1, 2, because from the center, on the X side, we are having 1, and on the Y side, we are having 2. So that is coordinate 1, 2. Then what about the radius? So from the center to the circumference, we are having a 1, 2, 3, 4, 5 units all through. So we have center, coordinates, center coordinates as a 1, 2, and radius is 5 units. So to get the equation of this circle, we just need x minus the x coordinate, which is 1 squared, plus y minus the y coordinate, which is 2 squared. This is equivalent to the radius also squared. Now with this, actually, radius squared is 25. Actually, this is already an equation to the circle. The format has not been spelled out. And because the format has not been stated, a student at this point is already having the equation in the general format. But the equation can be simplified, expanded, and modified into different formats. Like when we expand this, we shall get x squared minus 2x plus 1. Then on the y side, y squared minus 4y plus 4 equals to 25. And we can group terms here. We begin with x squared. We also go to the term that has y squared. This is one format of expressing. Then we go to the terms with x, the term with y, then the constants now. 1 plus 4, that is 5. Then 5 minus 25, it becomes negative 20. And we remain with a 0 here. So the equation can be into many formats, very many formats. But in this case, where the format has not been dictated, then the first statement is already correct. So that is how we approach that part. In part B, use the equation in part A to determine the x-intercept of the circle correct to 4 significant figures. Now, x-intercept of a circle is the point where the curve, where the circle is cutting the x-axis. X-intercept is the point where the circle is cutting the x-axis. Okay, graphically we can interpret that, but the examiner is encouraging us to use the equation. So according to this, we can have the x-intercepts because it's cutting the x-axis twice. The circle is cutting at negative 3.6 and also at positive 5.6. But the examiner is not looking for this. You're not supposed to read from the graph. Actually, you've been told to 4 significant figures. So instead of reading those points now, where the circle is cutting the x-axis, we use the circle. That means at the x-intercept, the values of y are usually 0. So we write x squared plus y is 0 to x minus y is 0 minus 20 equals to 0. So we are having x squared minus 2x minus 20 equals to 0. So this is the equation that we're supposed to solve for us to get the values of x when the curve cuts the x-axis. Yeah, so we're supposed to solve this one. Allow me use the completing square method, whereby I should be having x squared minus 2x equals to 20. 20 becomes positive, but I'm now supposed to add a constant here and also here. How do we add the constant? The constant is such that, I'm trying to make the left-hand side a perfect square. So it is such that b over 2 squared will give us that constant. So b is negative 2. When we divide it by 2, then we square. We shall get that constant. So negative 2 over 2 is negative 1. Squared, it becomes 1. So the constant c is 1. So we'll be having 21 here. And on the other side, we are having we can actually factorize it. To factorize a perfect square, we need the square root of the first term, x, the sign that follows, which is a minus, the square root of the constant, which is a 1 squared, equals to 21. Yeah, equals to 21 that way. With this, we can get the exact values of x now. So the value of x shall be, when we take square root both sides, x minus 1 equals to the square root of 21, which is plus or minus. Now square root of 21 equals to, and now I'm going to come up with the FOSF at this point, 4.583. 4.583. Yeah, to 4 significant figures. So x value equals to, when I take 1 to the other side, it will be added. So 4 plus, I will get 5.583. Then, did I really subtract? Did I really? Yeah, I've added 5.583. Then the other x shall be, when I take negative 1 to the other side, it will be added, but it's being added to the second option now of the square root, which is negative 4 point. So negative 4 point minus 1, it becomes negative 3.583. You see this one now is to 4 significant figures. And when I look at the curve, so in case we make them 1 decimal, it will be 5.6 and negative 3, also 0.6. And you see, these are the values we had read. These are the values we had seen just from the graph, but the examiner wanted a student to work out something. So that is how we approach that one. Number 8 is a question on errors and approximations. Yeah, errors, approximations. So we're going to look at the question. It's good for me to remind you that if you feel that you can support our programs, we encourage you to do so by using the till number displayed here. So Lipa na M-Pesa, you just support us with whatever you're having. for us to keep streaming lessons to help the Kenyan students. 49 777 42, Shifting Grades Online School. That is your platform. Continue inviting more friends. If you can, please support our programs. Otherwise, thank you so much for the continued support. We encourage you to send more friends to our platform. The length and width of a rectangle measured to the nearest millimeter are 7.5 centimeters and 5.2 centimeters, respectively. Find to 4 significant figures the percentage error in the area of the rectangle. Let me start by talking about the limits within which these dimensions have been recorded. And for us to get these limits, we have to consider the absolute values. So the absolute error in recording will be determined when we consider the accuracy. So what is the accuracy here? The accuracy is a millimeter. A millimeter is equal to 0.1 centimeter. So this is the accuracy used here. The accuracy of 1 millimeter, which is 0.1 centimeters. So 7.5 has been recorded to an accuracy of 0.1. So how do we get absolute error in the recording of dimensions? Absolute error is usually given by accuracy over 2. Accuracy divided by 2. So the absolute error in recording both these two dimensions. In other words, accuracy is the least measurement that can be recorded. The least measurement recorded. So if we are having 7.5, it means the next measurement will be 7.6, 7.7, 7.8, like that, which means there is an accuracy of 0.1. When we look at the width also, 5.2, that's an accuracy of, again, 1 decimal point, which is also 0.1. Therefore, from 5.2, we can go to a next value of 5.3, 5.4, like that. You know, if we are having whole numbers like 7, then this an accuracy of 1, whereby we say the next can be 8, 9, 10, like that. But now with a decimal place, the accuracy is 0.1. So we take 0.1 and we divide it by 2, we get 0.05. This is the absolute error in the recording of these two dimensions. So we can get the range of the two values. Range, the range, we can talk about range of the length. This one shall be, when we take the length of 7.5, we add or subtract the absolute error, 0.05, and this shall give us a limit starting from 7.45 after subtracting, that's the lower limit, all the way to after adding 7.55. It's my hope that I've subtracted well. Yeah. Then we have a range of width. For this width, which is 5.2, we add or subtract the same accuracy, the same absolute error. And that means we can talk about 5.15 after subtracting, all the way to the upper limit after adding 5.2. Therefore, with the limits or the range for the two dimensions, then we can get area maximum. Area maximum will be given by, you know, generally for a rectangle, area is given by length times width. So maximum area shall be the maximum length times the maximum width. We just use the upper limits. So I'm taking 7.55 multiplied by 5.25. This gives us 39.6375 square centimeters. And we can talk about area minimum, whereby we now use the lower limit, 7.45 by 5.15. This shall give us 7.45 by 5.15. This is giving us 38.3675 square centimeters. Then after this, we can now talk about actual area. Actual area is also called the working area. Working area is given by the dimensions just as they have been captured. So I'll be taking 7.5, and I multiplied by 5.2, and this is giving us 39 exactly. Yeah, 39 square centimeters. Now, with all the areas, we can talk about what we call absolute error in the computation of the area. You know, there is absolute error in recording, and now we have absolute error after carrying out operations. So absolute error is usually given by maximum minus minimum over 2. So we will talk about 39.6375 minus 38.3675. Then we divide this by 2. Let's check what we will get as the absolute error. 39.6375, then I subtract 38.3675, then I divide this by 2. I'm getting 0.635. That is called absolute error. Maximum minus minimum out of 2. Let's go to the next. We talk about now the relative error, which is given by absolute error out of actual area. So we'll be having 0.635 out of 39. Then we talk about percentage error, which is given by relative error multiplied by 100. So we'll take the relative error and I multiply it by 100. This one divided by 39, then I multiply by 100. I'm getting 1.6. 4 significant figures again, according to the instructions here. It's good for you to read questions carefully. To 4 significant figures. So I'll be having 1.6 to 8%. That is for SF. Very good. You see? So our work is very decent. It's good for me to remind you something. Whenever you are working out this topic, it's good for you to be fully prepared. You might think it's a totally paper 2 concept, but sometimes it will fix you with a paper 1 concept. In this case, they will give you the radius and height of a cone. Then they will tell you to find the percentage error in the volume of the cone. Therefore, you will find yourself having to remember the formulae used to calculate the volume of a cone, the surface area of a sphere, the volume of a cylinder. A lot of things. You are supposed to be fully equipped. So don't just master the errors part. Master some formulae that will help you in the exam time. Let's get to number 9, some geometry. The figure below shows a circle and a point A outside the circle. We can see point A very well. Look at part the question. now the question part. Using a ruler and a pair of compasses only, construct two tangents from point A to the circle. So the first thing that we're supposed to do here, ladies and gentlemen, will be identifying the center of this circle. Now, to identify the center of the circle, people should know that any chord bisected, the bisector passes through the center of the circle. So we are going to draw random chords, a random chord. I can even have it here. Let me use a different color, sorry. A chord at that point. Then now, I'm supposed to bisect this chord. I'm supposed to bisect this chord. And I should do so perpendicularly. So when I bisect this chord, the bisector will automatically pass through the center. The bisector will automatically pass through the center. Remember, we are using a ruler and a pair of compasses only. So we do a bisection here and we connect through the center. We just prolong this bisector. We bisect a chord, a random chord, a chord that you did not even measure the length. That chord will pass through the center of the circle. So we do that, and we get another chord somewhere, and we also bisect it. This is another chord, so we can bisect it. This particular chord can also be bisected, and we do so perpendicularly. So we're supposed to bisect it perpendicularly, and we will know that when bisected, it will pass through the center. So we stand at this point, we make an arc. Standing at this point, we also make an arc. So when we join, that will be a bisector, and it will pass through the center of this circle. That way. So this one becomes point O, the center of the circle. That becomes the center of the circle. That way. So now that we are having the center of the circle, now we can proceed to draw tangents. Drawing a tangent from an external point means we first join point A to the center of the circle. We join point A to the center of the circle. Then after that, we bisect the line. We bisect the line, which is a line OA. We bisect it. So I'm going to bisect this line perpendicularly. The line from O to A. Yeah, so we will bisect it perpendicularly. So we must bisect it very keenly, perpendicularly. Remember, we are using a ruler and a pair of compasses only. Yeah, so we stand at this point and we make an arc. Okay. What you will do is that you will stand at a point A. Stand at A, you make an arc, and you make another arc. Then you come back to point A, point O, using the same. You also make arcs. Then now you connect these arcs. You will come with you will come up with the bisector. And by the way, the main intention here is to identify the center, not even to raise the bisector, just to identify the center. So now we have seen the center of OA. After seeing the center, now you are supposed to stand at point, you're supposed to stand at point O and use the center X. You use point OX now, use radius OX. Use point OX as the radius, and standing at X, you make some marks. You make a mark. You make a mark on the upper side, and you also make another arc on the lower side that way. Now, in case we connect point A to the arcs produced, we will get our tangents. Yeah, we will get our tangents from point A to the circle. So that is a tangent. Then using the other side, that's also a tangent. So we are having two tangents. This is now the tangent. The yellow line is the tangent now. That is the tangent. And also this one is a tangent. A very simple procedure. But initially, you were supposed to come up with the center of the circle. Very key. Coming up with the center of a circle, which is you come up with random chords and you bisect them. That way, the intersection of the chords will give you the center of the circle. Now in number 10, look at number 10. And I hope you guys are seriously following. You should comment. You can let us know your institution. Let us know whether you are benefiting from this program. Let's know your school. Let's know where you're watching us from. Are you benefiting or not? Okay, number 10, make K the subject of the formula. So we are already having the formula here, T equals to M minus PK squared divided by NK squared minus N. So let's start by across multiplication to do away with this fraction. T should multiply everything such that we have M minus PK squared. That one remains that way. Equals to, now T multiplies everything. T N K squared minus T N minus T N. Now, at this point, we can group the terms with K together and the terms without K to another side. So this negative Tn can be brought here such that we have M plus Tn. Because it was negative on the right, it becomes positive. Then now, we are already having Tnk squared. Then Pk squared, which is negative, now becomes positive to the right. Pk squared. You see, K squared now is to the same side. So we can factor out K squared to remain with the Tn plus P. This is equal to M plus Tn. Now, can we remain with K squared alone by dividing through by Tn plus P? So M plus Tn out of Tn plus P, that way. So now we can remain with K alone because K squared has been expressed. Now we can remain with exactly K by saying K is going to be the square root. And we talk about plus or minus the square root of M plus Tn out of Tn plus P, that way. So this is the final answer and the final expression of T. I want to give some precautions. There are people who will forget the plus or minus. That's a mistake. So somebody saying that K equals to M plus Tn over Tn plus P. That way, this person is wrong. want to see you, I want to be showing you the wrong expressions of k. K equals to, you write the square root very well. You actually include plus or minus, but you're having m plus tn out of tn plus p. This is wrong because your square root is covering the upper part only. Your square root, actually you'll put it this way and you think it's this way. Now, this is very wrong. The square root sign should cover. The square root sign is supposed to cover. It's supposed to cover both the numerator and the denominator. And you're also supposed to extend it up to the last term because it's the square root of everything. Square root of everything. So you can even have it this and you get it wrong. You have it covering, but you have it slightly on the first terms. M plus Tn out of Tn plus P. You see, it is only M and Tn which are under the root sign. The other terms are outside. So you're supposed to ensure that you cover everything, then plus or minus for you to get it. So that's how you're supposed to be very careful in expressing K as the subject of the formula. Now we are in number 11. The population growth of a colony of insects was recorded at intervals of 5 seconds as shown. So initially it was 5. After 5 seconds, they went to 7. After 10, we had 11, like that. You can see the table there. On the grid provided, draw the graph of the population of insects against time. So now, when you hear graph of population of insects, these ones are on Y against time. Time is on X. So time is on X, this is on Y. So we have coordinate 0, 5. That is the first coordinate. 0, 5 is the coordinate. Let me use a different color for the coordinates. That is the first coordinate. The second coordinate is a 5, 7. So 5, 7. 7 is slightly above 5. So 5, 7 is there. Then we are talking about 10, 11. 10, 11. 11 is slightly above 10 there. Then we talk about 15, 16. 15, 16. 16 is also above 15 at this point. Then we have a 20, 24. 20, 24. 24, slightly below 25. Then 25, 36, the last coordinate. 25, 36. Below 35. That's where we are. So the graph is suggesting a very smooth curve. And that is what we are supposed to draw, a smooth curve. So let's do the curve. So a smooth curve using your freehand and not the calculator, and not the straight ruler. You just use your freehand that way to join the coordinates. After plotting, the plotted coordinates are supposed to be visible, like mine. So you don't use a dot that you will block using the curve. So that is it. We are having now the curve. Then look at part B of this. Use the graph to determine the average rate of change of the population of insects between t equals to 7 and t equals to 23. T equals to 7. Let's look at t equals to 7. At 7 visits. How many insects are there? I'm getting 9. So average change at that point, we will need the gradient. Average change, we will need the gradient at that point. So we're supposed to do a gradient at that point, and we get the coordinates of points along. Gradient at that point will be gradient at a tangent. That way. So at t equals to 7, we can use that one. We can use that gradient to get the coordinates. So we are using a coordinate 7, 9, and any other coordinates along the tangent. So along the tangent, we can have very many coordinates like this one. This is a 14, 13. So let's get the rate of change there. So the rate of change is going to be, we take gradient, 13 minus 9 out of 14 minus 7. So the rate of change is going to be 13 minus 9, which gives us a 4, and 14 minus 7, which gives us a 7. That's the rate of change at t equals to 7. Then at t equals to 23, at t equals to 23, we can draw a tangent also at that point. T being 23, 20, 21, 22, 23. So 23 will be at this point. Yeah, at that point. That way. So that we talk about 23. Okay, we do a tangent there again for us to get the rate of change. Do a tangent at that point. Rate of change. So we get 23, 29, and we use another coordinate, which is on a coordinate on the tangent drawn, not on the curve, on the tangent drawn. So I can pick a coordinate at this point, which is 28, 39. Let's get the rate of change. 39 minus 29 and 28 minus 23. This is going to be 10 over 5. This is going to be 2. So the rate is 2, and the other rate was 4 over 7. So average rate is going to be, when we take the two rates now and we divide them by 2. The rate at 7 is 4 over 7. The rate at 23 is 2. So average rate means the two rates divided by 2. This will give us 1 and 2 over 7. So that is the average rate. The average rate. So that is it. Number 12. Simplify the expression 4 divided by 2 tan 960 minus 3 divided by 2 plus the tan of 960, leaving your answer in surd form. So this is a trigonometry 2 together with surds. So allow me first identify the acute angle, which will be equal to 960. So take a unit circle. Then we are having the quadrants there. So when we use the first cycle, we have an angle of 360. So 360. And when we move again, we get a complete circle again, we get 720. That means we should continue moving until we cover 960. So 720, when we add 90, we get it 10. What about when we add 90 once again? We'll get 900. That's 900. That means we need 960. So we move for a 60 now. Move for a 60. That means an angle of 960 is the same as an angle of 960 is the same as 60 degrees in the third quadrant. So we identify an acute angle and the quadrant it lies. The quadrant it lies. Very important. So tan 60 will be the same as tan 960. And the way angles in the third quadrant behave is the same way 960 shall behave. So we usually say that all the angles in the first quadrant, all the trigonometric ratios are positive, sines alone, tangents alone, then cosines alone are positive here. Therefore, in the third quadrant, tangents are usually positive. Therefore, the value of tan 960 equals to tan 60 and it is positive. Now, in surds, tan 60 is usually given as the square root of 3. So we need root 3 now. Therefore, this expression is 4 out of 2 minus root 3 minus, sorry, these are minus 3 out of 2 plus the root of 3, that 2. So now we can talk about, because the third will be treated just like a normal fraction, I'm going to have the LCM 2 minus the root of 3 into 2 plus the root of 3. Therefore, when I take the LCM, divide by the first denominator, I will get 2 plus root 3 because 2 minus root 3 will cancel. So I will have 4 into 2 plus root 3, then minus 3 multiplied by. When I take the LCM and I divide by the second denominator, I will have 2 plus root 3 cancelling. So I remain with 2 minus the root of 3 that way. So this because of the brackets, I'll have 8 plus 4, the root of 3, then minus 6. Then this becomes now positive, the root of 3. Positive 3, root 3, that way. Then divided by, assuming that you were not present in my previous lesson, then I'm going to teach you how to rationalize this denominator. It's already a factorized form of a difference of two squares, and the first bracket and the second one are called conjugates of one another. So how do we expand a surd together with its conjugate? Now, to multiply a surd with its conjugate, we are doing something called rationalization. So at the end of the day, we will not have a surd at the denominator because we are multiplying a surd and its conjugate. When we are simplifying x squared minus y squared, this is called a difference of two squares. You simplify it to x minus y, x plus y, which means you can use this trigonometric identity to expand a simplified difference of two squares. And that means at the denominator, we'll be having 2 squared minus root 3 squared. So that will be 4 minus 3. Yeah, 4 minus 3. Then now we can group a few terms on the numerator such that we are having 8 minus 6 giving us 2, then plus 7, the root of 3, divide by 1, meaning that the answer is 2 plus 7, the root of 3. So this is now the most simplified answer. the most simplified answer that way. Number 13, we are again on trigonometric equations. In this case, we are dealing with trigonometric identities in trigonometry 3, that is book 4 work, whereby we know that whenever we have a sine squared of a certain angle plus the cosine squared of the same angle, we're supposed to get 1. This means that we can make cosine squared the subject and take 1 minus the sine squared of beta that way from the same trigonometric identity. So here I'll be having 6, and instead of the cosine squared of x, now I'll have 1 minus the sine squared of x plus 7 the sine of x minus 8 equals to 0. So this is 6 minus 6 sine squared of x plus 7 sine of x minus 8 equals to 0. At this point now, we can group some terms. Let me take negative 6 sine x squared to the right, where it will be positive. 6, the sine squared of x is positive. Then 7 sine x will become negative on the other side. Then now we are having 6 minus 8, which is negative 2. Now it should become a positive 2. So that on the left, we remain with a 0, but we take it to the right so that we have a quadratic equation, which is having the right format that way. So now we can let the sine of x to be another unknown, talk about even t. So 6 t squared minus 7 t plus 2 equals to 0. So we can talk of solving this equation and use even the factorization method, whereby we shall say we need a product of a times c, which is 6 times 2, 12, and a sum of b, which is a negative 7. So negative 4 and negative 3 that way. Negative 4, negative 3. Those are the factors when multiplied, positive 12, when added, negative 7. So now 6 t squared minus, instead of 7 now, we replace it with negative 4t and negative 3t. Then we have the positive 2 equals to 0. So we factor out 2t from the first two terms, so that we remain with 3t minus 2. Then we subtract 1 here. We factor out negative 1, so that we are remaining with 3t minus 2 equals to 0 that way. So with this, from the inside of the brackets, we're having 3t minus 2. Then from outside the brackets, we have 2t minus 1. This is equal to 0. The values of t are going to be several here, because 3t minus 2 can be equal to 0, translating to t becoming 2/3. Again, 2t minus 1 can also be 0, meaning that the value of t will be half. Exactly that way. Therefore, we can say that, oh yeah, we have some space here. The sine of x equals to t, because it is what we had let to be t, equals to 2/3, and also the sine of x equals to half that way, which means we can get two possible values of x. X equals to sine inverse of 2/3. X equals to the sine inverse of half. So sine inverse of 2/3 You go to your calculator, shift sign 2/3, and I'm getting 41.81 degrees. Then shift sign 0.5, I'm getting exactly 30. So we have two acute angles here, two acute angles, but looking at the range provided, it means we have to get some more angles. So the first angle can be 30. The other angle can be 41.81. The other angle can be, now we have to go to using the unit circle, we go to the quadrants where sign is positive. Where sign is positive, and that is the second quadrant. Second quadrant. So following the unit circle, you see that all of them are positive, but signs are positive here, cosines are positive here, and tan is positive here, and cosines positive in the last. Okay, yeah, T at this point. Therefore, we are talking about now, here we have the acute angle beta, but here, for us to get the equivalent angle, to take 180 minus beta. In case we wanted the angle in the third quadrant, the angle would be gotten by 180 plus theta. Equivalent angle in the last should be 360 minus theta. Now that we have theta and their two values, and we need equivalent angles in the second quadrant, it will be 180 minus 30. 180 minus 30, then 180 minus 41.81. So when we subtract 30, we get 150. The other possible angle is 150 degrees. And when we subtract 41.81, we will get 138.19. So these are the four possible angles which are satisfying the above equation within the provided range. Looking at number 14, the area of the image, the area of the image of an object after two successive transformations given by 2, 1, 3, 5 and 3, 1, 0, 1 in that order is 168 square units. Find the original area of the object. There's something here that we're supposed to know. We're supposed to get one matrix which is equivalent to the successive transformations. That is now Form 4 work. And we're supposed to know that if this matrix was performed first, then it will be written as 2, 1, 3, 5. And if the second one was performed last, it will be written here 3, 1, 0, 1. That is what you're supposed to know. If I write two matrices this way, it means this one was performed first, followed by this. In other words, assuming this is matrix T and this is matrix M, when I write them as MT, I mean T was performed first. So that's why I've written them that way. Now, when I take the product of these two matrices that way, I will get one single matrix that represents one single matrix that represents the successive transformation by the two of them. Therefore, I should multiply now row times column. That is a 3 by 2 and 1 by 3. That is 6 plus 3, 9. Then the same row by the second column, 3 by 1 and 1 by 5. That is 3 plus 5, 8. Then on the lower side, I go to the second column, the second row, 0 by 2 and 1 by 3. That gives us 3. Then I also talk about 0 by 1 and 1 by 5, giving us 5. So this is the single matrix of transformation. Single matrix of transformation That would represent the two matrices. Now, we're supposed to know that area scale factor equals to absolute value of the determinant of the responsible matrix. So we get the date now. The determinant is given by product of elements in the main diagonal, that is the main diagonal, 9 by 5, minus product of the elements in the other diagonal, 3 by 8. So I'm getting a determinant of 45 minus 24. This will give us exactly 21. So the determinant is 21, which means area scale factor is 21. Now, area scale factor is usually given by area of the image out of a known area of the object to give us 21. So to get x, we need 168 out of 21, and this is giving me exactly 8 square units. So this was a deep concept, and a learner is supposed to understand how matrices are multiplied to give us one matrix which is responsible of a successive transformation. The matrices are multiplied starting with the one which was performed last. Then the one that was performed first is written last. Then you get the product that way. We are looking at number 15. Given the equation 3y equals to 2, the sine of 3x minus 30, determine the amplitude and the phase angle. So we're supposed to know that generally, when you're given a certain trigonometric function, y equals to, let's say, a, the sine of x multiplied by theta, then minus a certain angle. You know, we can say instead of theta, we can use a x. So let's say a multiplied by x, then minus a certain angle. In this general function, we're supposed to know that a is usually the amplitude and the absolute value of theta is usually the phase angle. Then when we take 360 and we divide it by a, we're supposed to get period of the wave, trigonometric wave. Therefore, in this one, we will be talking about, we divide first to remain with y. Yeah, that way we must be very careful. We are not having y, we are having 3y. Sine of 3 theta minus 30. So this means amplitude equals to 2/3 and the phase angle equals to 30 degrees. That way. Then finally, we're having a number 16 here. Then later we'll be doing the section 2. The length of a rectangle is 3 times its breadth. The breadth is decreased by 2 meters and the length increased by 4 meters. The area of the rectangle is decreased by 1/3. Find the area of the original triangle. So let me interpret this. We are told that the length of a rectangle is 3 times its breadth. So if we rate the original breadth to be x, then the original length is going to be, the length of the rectangle is 3 times 3x that way. If the length, if the breadth in the second statement now, the breadth is decreased by 2. So breadth, new breadth becomes x minus 2, and the length increased by 4. New length becomes 3x plus 4. The area of the rectangle is decreased by a third. It's decreased by a third. So if it is decreased by a third, you know, original area was 3x by x, which is 3x squared. So now the new area is becoming, if it has decreased by a third, you know, it should become 2/3 of the original. It should now become 2/3 of the original. I hope that language is now clear. If it is now decreasing by a third, it means the new area is 2/3 because it has decreased by a third. So this shall be 2x squared. Yeah, that is now the new area. Therefore, x minus 2, 3x plus 4 should give us 2x squared. Then we are going to find the value of x. So when we multiply x by 3x, we get 3x squared. Then again, x by 4, we get 4x. Then negative 6x. Then negative 8 equals to 2x squared. So 3x squared minus 2x minus 8 equals to 2x squared. When we group some terms here, 3x squared, we subtract 2x squared and get x squared. Then minus 2x, then minus 8. This is equal to 0. Can we talk about a product which is equal to a by c, negative 8, and a sum which is equal to negative 2? Then the factors will be negative 4 and 2. When multiplied, negative 8. When added, negative 2. That way. So the value of x shall be either 4 or negative 2. And because we are dealing with length, x cannot be negative. So the value of x shall be 4 centimeters. That means we are having the original breadth. Find the area of the original rectangle. So original rectangle is measuring now 4 by 3 is 12. So area shall be 4 by 12, giving us 48 square centimeters. Or we could have said the area of the original is 3x squared, which would be 3 and 4 squared. You know, 4 squared is 16. 16 by 3 is still 48. So we get the same. Later, we'll be discussing the section 2 of the same paper. Remember to support our programs by just going to your Lipa na M-Pesa and to use the till number 49777742. Then we shall keep growing together. Thank you so much for following. Remember to subscribe and to share this lesson.